Breaking news. At 0142 UTC this morning, automated alert systems lit up across observatories on 3 continents. Data streams from space-based telescopes and ground stations began flashing red within seconds. In California, Germany, and northern Chile, scientists watched the same impossible pattern unfold in real time. Today, the impossible just happened. Moments ago, the interstellar object known as 3I Atlas entered a previously unobserved physical phase, just 48 hours before perihelion, its closest approach to the Sun. This was not a routine fluctuation, not a simple thermal response. Instruments recorded coordinated changes in motion, structure, and emission. An object we believed to be inert, cold, ancient, and predictable, has begun to behave as if it were active. This changes everything we thought we knew. If you want real-time updates on the most mysterious cosmic events ever recorded, make sure to like, subscribe, and stay with us, because what you're about to hear is not speculation, it is data, and it is unprecedented. The confirmation did not come from a single telescope or a lone analyst staring too long at a noisy screen. It came from a convergence of the most advanced scientific infrastructure humanity has ever built. NASA's Deep Space Network first detected an anomalous shift in Doppler velocity during a routine orbital refinement. Minutes later, ESA's European Space Network flagged a correlated disturbance in radar echomorphology. Almost simultaneously, the Atacama Large Millimeter Array in Chile reported a non-random redistribution of thermal emission across the object's surface. At Harvard's Center for Astrophysics, graduate students were instructed to halt simulations mid-run. At Caltech's Jet Propulsion Laboratory, senior scientists were pulled into emergency briefings before sunrise. The James Webb Space Telescope, operating in near-infrared bands between 0.6 and 5 microns, was quietly retasked. Hubble followed, cross-checking visible light albedo changes. Radio arrays in South Africa and Western Australia were brought online, searching for correlated electromagnetic disturbances. This was not one instrument malfunctioning. This was consensus. 3I Atlas was first identified as interstellar because of its hyperbolic trajectory and excess velocity, approximately 42 kilometers per second relative to the Sun, far too fast to be bound to our solar system. Its origin lies beyond our planetary neighborhood, likely from another star system entirely. For months, it behaved like a quiet visitor, tumbling slowly, reflecting sunlight unevenly, emitting faint traces of volatile gases. Until now. 48 hours before the present moment, everything appeared deceptively normal. Orbital elements were stable. The object was approximately 1.3 astronomical units from the Sun, inbound but still cold, its mean surface temperature hovering near 140 Kelvin. Spectroscopy showed composition consistent with carbonaceous material and water ice, with trace silicates. No jets, no rotational instability, no warning. Then came the anomaly at T-48 hours. Tracking stations in Goldstone detected a deviation in acceleration, just 0.04 millimeters per second squared. Insignificant on its own, but when Madrid and Canberra independently confirmed the same vector change, analysts paused. There was no corresponding outgassing force. Solar radiation pressure could not account for it. 11 hours later, thermal maps from Atacama revealed something stranger still. Heat distribution across the surface began to reorganize. Instead of a smooth gradient, hotter on the sunward side, colder on the trailing edge, the object displayed segmented thermal zones, fluctuating by nearly 30 Kelvin in less than 20 minutes. No known passive process could account for such rapid thermal homogeneity in deep space. 6 hours after that, rotational light curves changed. The periodic dimming and brightening suggested that 3I Atlas was reducing its chaotic tumble and settling into a single-axis rotation. Angular momentum appeared to dissipate without a detectable energy sink. The object was stabilizing itself. 2 hours before the phase transition, visible light spectroscopy showed a subtle color shift. Reflectance in the blue band dropped by 7%, while near-infrared reflectance increased. To material scientists, this suggested a surface restructuring, possibly a phase change in subsurface compounds migrating outward. But the timing was too precise. Then came the moment that changed the conversation entirely. At 0142 UTC, interferometric imaging resolved a structural adjustment. 3I Atlas, previously elongated with an aspect ratio near 4.8 to 1, began compressing along its major axis. Over the next 39 minutes, its silhouette transitioned toward a more symmetrical configuration. Not spherical, not random, but precise. The change amounted to a 12% reduction in length and a corresponding expansion in width. Total volume remained constant. Mass estimates, derived from gravitational perturbations on nearby dust grains, did not change. No natural process could produce such symmetry on that timescale. Within minutes, emergency calls were placed. Dr. Elena Moravec at ESA's Space Situational Awareness Program initiated a cross-agency verification protocol. Dr. Jonathan Reyes at Caltech ordered immediate N-body simulations to test whether tidal forces or solar radiation pressure could be responsible. They were not. As the hours ticked by, the anomalies escalated. 3 hours after the shape change began, ultraviolet spectroscopy detected a transient emission at 121.6 nanometers, hydrogen Lyman alpha, pulsing at regular intervals, every 18.2 minutes. The intensity was low, but the regularity was unmistakable. Radio telescopes then detected faint broadband emissions between 1.4 and 1.6 gigahertz, not narrowband, not a message in the traditional sense, but structured oscillations, repeating with mathematical precision. Prime number intervals emerged in the modulation pattern: 2, 3, 5, 7. This was no longer random. This was responding. At MIT, gravitational modeling ruled out internal collapse. At the Max Planck Institute, material physicists confirmed that no known ice rock composite could reconfigure itself without catastrophic fracture. At Stanford, computational analysts ran machine learning classifiers trained on millions of cometary and asteroidal datasets. None matched. 2 hypotheses began to crystallize. The first, the mainstream explanation, held that 3I Atlas might be an exotic natural object, perhaps a relic of an ancient stellar collision composed of ultra-dense anisotropy material capable of undergoing low-energy phase transitions. Under increasing solar flux, internal structures could reorganize, releasing stored stress and producing anomalous emissions. Proponents pointed to the unknowns of interstellar chemistry, to physics yet undiscovered. The second hypothesis was more unsettling. It proposed that the object was not passive, that the observed changes were controlled, intentional, technological, or the product of physics far beyond our current understanding. Dr. Marcus Hale of Harvard, speaking behind closed doors, purportedly stated, "If this were occurring in a laboratory, we would call it active matter." Then came the second wave. 17 hours after the initial transformation, a localized region on the object's trailing edge simply vanished. Not detached, not sublimated, it disappeared from optical, infrared, and radar detection simultaneously. No debris, no plume, no energy spike. The remaining structure adjusted within minutes, redistributing mass to maintain balance. At the same time, magnetometers aboard Earth-orbiting satellites registered a localized disturbance, a fluctuation of 0.3 nanotesla, synchronized precisely with the object's pulse interval. Minor, harmless, but unprecedented. Inside mission control rooms, the atmosphere shifted from curiosity to silence. Encrypted communications increased, data access was restricted, analysts noticed delays in public releases, world governments were briefed, not on conclusions, but on uncertainty. Subtle effects followed. a cluster of low Earth orbit satellites experienced transient communication dropouts, radio blackouts flickered over the South Pacific, navigation systems reported nanosecond-scale timing errors. Migratory bird tracking data showed deviations of several degrees from predicted routes, coinciding with minor geomagnetic anomalies. No one panicked, but no one slept. As perihelion approached, emissions from 3I Atlas intensified. Infrared output rose steadily, yet internal temperature gradients flattened, as though heat were being redistributed deliberately. Pulses became more synchronized, spectral lines sharpened. Fragments did not form. Jets did not appear. Instead, the object entered what researchers began calling an unexpected phase, a state of ordered activity. At T-24 hours, gravitational modeling revealed something even stranger: micro-adjustments in trajectory, on the order of meters per second, executed without visible thrust. The object was making corrections, subtle, precise. No comet does this. At T-12 hours, radio emissions shifted into a tighter band, centered at 1.42 GHz, the hydrogen line, the most universal frequency in astrophysics. Pulse intervals shortened to 13 minutes, then 8. Prime numbers again. This was no longer random, one internal report stated. It was responding. Control rooms became theaters of quiet intensity. Analysts leaned over glowing displays. Engineers whispered into headsets. Simulation clusters ran at full capacity. In one leaked message, a senior systems scientist wrote simply, "We are observing coordinated behavior." As perihelion drew closer, 3I Atlas stabilized into its new configuration, smooth, faceted, exhibiting rotational symmetry to within 0.01%. Its trajectory remained hyperbolic. It was not stopping. It was passing through. I remember staring at the data feed as the last update came in before dawn. The numbers were calm, the graphs smooth, and yet nothing about them felt reassuring. Because for the first time, we were not just observing an object behaving strangely, we were witnessing behavior. In the quiet moments that followed, reflection replaced urgency. For centuries, we believed the universe was indifferent, a vast stage of matter and energy following immutable laws. But what if some of those laws include agency? What if intelligence in some form is not rare, but simply subtle? Maybe we are not witnessing the end of certainty. Maybe we are witnessing an invitation. As 3I Atlas continues its silent journey toward perihelion, instruments remain locked on target. Every pulse is logged, every fluctuation analyzed, every deviation from expectation archived. The data keeps coming, the questions keep growing, and one thought refuses to fade. What happens when it changes again? Subscribe to follow the next update, because the story of 3I Atlas is far from over.